So without further ado, Devin's going to be presenting his talk on Python tooling for the Snap community. All right, Devin, the floor is yours.
Yep, okay, let me just check. So does everyone see the slides all full screen now?
I do.
Okay. Okay, so I'm Devin Jean. I'm a grad student at Vanderbilt University, and we'll be talking about Python tooling for the Snap community. So there we go. Okay, so first, just to give a little bit of background. So we're going to be talking about block-based languages, which I would hope everyone is familiar with by now. If not, welcome to SnapCon. So these are fantastic for introducing programming to students, and they get rid of a lot of the problems that students face when they're trying to learn programming initially. Just by block snapping together, they don't let you do a lot of the wrong things. And importantly, they give you access to effortless concurrent execution, so we can have multiple green flag clicked scripts with forever loops even that never finish, and they'll all execute semi-concurrently, just like students would kind of intuitively think they would. And the only downside to this is that some of the more advanced students, especially older students, might want to move on to textual languages at some point. And this is problematic for a few reasons, not the least of which being the textual languages themselves. So here we have a little bit of C++ code, and we can already see that it's a little bit disgusting, to say the least, if you're coming from a block-based language where everything is all nice and neat, and we don't need all this boilerplate. Like, for instance, there's a lot of things that just don't make sense why they're needed initially. So like pound include, it's not entirely clear what that does. It's not clear why it's less than IOStream and greater than nothing. Of course, that's not what that means, but it is what it looks like it means if you don't know. It's also unclear what int main is and all of this other stuff. You might think, students might think maybe that's like a green flag clicked, and I guess it sort of is, but if you try having multiple of them, your program won't compile suddenly, and it's not obvious coming from a block-based language with concurrent scripts why that's the problem. And there's a lot of complexity like this that we won't get into. And and another thing is that projects that are in textual languages are typically not graphical or concurrent without great effort involved and a lot of more complicated libraries that we also don't want to delve into. And because of this, there's just a lot of unfamiliarity that students have, and that's really bad for their ability to learn. They might be let down that they can't build the same projects and feel like they might not be making progress, which just complicates their learning process too much. So this tool that we're going to be talking about is extended from NetsBlox, so I'll just give a little bit of information about that, although we did have a previous talk in this session talking about it, so I won't go into too much detail, but it's basically an extension of Snap, which adds a bunch of networking related features. For instance, remote procedure calls like we already saw, and message passing between projects, which allows basically a structured packet of information to be sent from one project to another over the internet. Potentially, they could be running on different computers anywhere in the world. So we can make a data type called, for instance, my data type, and give it 3 fields, X, Y, and Z, let's say. And we can send this structured block of information to some target over the network, and that target can receive it. It unpacks the fields automatically, making them variables, and they can do whatever code they want. So that's those are basically the 2 networking primitives that NetsBlox provides. Now, the benefit is that this has already been shown to be highly effective at teaching some of these advanced networking concepts to K-12 audiences, which is great, but the problem is that students might eventually want to move on from NetsBlox to other environments such as textual languages. And the reason this is a problem, like we already discussed, textual languages are a lot more complicated than their block-based counterparts, and networking features are no exception. Often this even involves asynchronous programming, which is beyond the extent of this talk. And we do not want to dump any of this complexity on top of everything else just with learning an entirely new language. So because of these, students typically, if they try to transfer to a textual language, they'll lose a lot of these advanced networking concepts that we taught them in NetsBlox and basically just regress to making more simple projects. So the solution that we're going to try to propose is PyBlox, which is a fully featured Python interface to NetsBlox. And specifically, or more generally, we're going to be talking about 3 key features that block-based programming environments provide that users know and are intuitive, and that we should and can actually use these aspects and transfer them over into other learning tools for programming, just using other languages or environments. Not necessarily textual environments, it could be other visual programming environments. So the first of which we already talked about a little bit is concurrently executing scripts. So we have a few pretests that we've done with students in the past, actually recently are the ones that I'm referring to. So I can't show the actual pretest results that students wrote. It was pseudocode they would write. But a lot of students actually, their programs inherently used some element of, or some implied notion of parallel execution of their scripts, which was a little surprising, but actually it's interesting that they before we even taught them anything, because this is the pretest, they were already thinking in terms of concurrently executing code. Snap does this really well, like we've covered with the hat blocks and multiple scripts that can execute at the same time. But textual languages don't really. So we need to build a bridge to be able to get students who are familiar with block-based programming to be able to use this in some other environment. Another is event-based computing. So a lot of times when we do projects with NetsBlox, the go-to input method that students use is actually just keyboard commands like arrow keys or spacebar, things like that. Now, the issue is that a lot of textual languages, the input is line-based. So you might ask a user for a line of input, they enter some text and press enter, and you get the entire line. But what you don't get without using some extra more complicated libraries are things like individual arrow key presses or spacebar and things like that. So we also need to provide on top of an event-based system a way to get raw access to the peripherals like the keyboard and mouse. And the last thing we're going to talk about is the graphical environment. So students love to make graphical projects. They just do. But the downside is that, again, textual languages are very much terminal-based a lot of times, depending on which language that you're using, of course. But a lot of them are terminal-based in their pure form. And this is really intimidating. Terminals are very intimidating, and they prevent visual organization because they're so linear. It's just lines of output stacking top to bottom. And without more complicated libraries, it's not even easy to erase something and put something else there. You basically just stack on things on top of each other very linearly. So here we have the PyBlox IDE. So as you can see, if you're familiar with Python, this is a Python environment, hence the Py and PyBlox. So what we want to do is make this as familiar as possible for students. And you can see the interface is kind of designed with this in mind. So for instance, project code is broken into tabs for the stage and the various sprites, just like they are in NetsBlox and Snap. And it provides a nice separation of code and separation of concerns for the students. The actual editor itself has typical IDE features like syntax highlighting and context-aware completion suggestions. One really nice feature that Snap has, and NetsBlox by extension, is that you can right-click on a block and go to help to actually get some contextual information about what the block is, how it works, how to use it. But the downside is I've seen when we would try to get students to be using these tools in NetsBlox, we might show them how to access the help menu, but later on, even if they're struggling with using some block, they frequently don't look at the help information. So one of the ideas here is that we can just force them to look at it by putting it front and center. Basically, anywhere you move the cursor in the editor, so if you highlight turn right or just put your cursor on it, it will automatically update the documentation panel to show information about that function. We also include a customizable palette of blocks, which students are familiar with, and you can drag and drop these into the code editor to paste a code snippet. See this @onStart decorator is basically equivalent to a when green flag clicked, but of course, students who are new to this, although they might know when green flag clicked and they might know that they want that, they don't know how to get it in the Python environment. So we just provide basically the elementary building blocks that they would need to start transferring their code over into a text-based environment. Now, PyBlox code itself, we try to keep basically a one-to-one correspondence. So when green flag clicked is equivalent to @onStart. The position of the sprite and the heading are accessed as attributes on the sprite entity, as well as movement like going forward, turning left and right by a certain number of degrees, things like that. And all the events actually, all these curved hat blocks are decorators that are applied to functions. So when the up arrow key is pressed is equivalent to @onKey up arrow. And PyBlox just behind the scenes will take care of making sure that all the scripts execute concurrently like students expect them to, just like they would in Snap. So we also provide, of course, broadcasting and receiving messages. Now this is done through decorators like netsblox.onMessage and netsblox.sendMessage. Now you might be wondering why those are NetsBlox specific when everything else isn't. And the reason is because these are actually the exact same interfaces that are used for NetsBlox message passing. So not only can you broadcast a message to other sprites in your project locally, you can also specify a target, in which case it'll send it to another project running anywhere in the world. That could be a NetsBlox project or another PyBlox project. And of course, we also give access to all the NetsBlox RPCs. So if you want to call the Mauna Loa CO2 data service and get CO2 data trend, you can just do nb.maunaloaco2data.getCO2 trend. And the context-aware completion, so when you do nb dot, it'll give you a list of things that you can auto-complete here. So that helps with discoverability. So this has basically similar complexity to the block-based code. Now, students do need to learn some of the syntax of Python, of course, but there is otherwise a one-to-one correspondence between what things do in blocks and in PyBlox. So students can focus on learning the Python syntax itself, and that also means that any curriculum that was already using these same features can pretty much port over directly into a text-based environment with Python, and students can continue learning with the same curriculum, doing the same kinds of stuff, building the same types of projects that they were before. So now I'll just move over and actually see the tool. So here we go. We have the PyBlox IDE, and let me know if I need to zoom in and make this bigger or anything. So let me see, there is a, yes, here we go. There's this project here, which is an equivalent. So all it's going to do is it has two variables, counter1 and counter2. So we'll have 3 concurrently executing scripts that just run forever. One will change a counter value by 1, well, counter1, the other changes the other counter. And then the third script just prints out the values directly. So we actually saw that this was a pattern that was used in some of the solutions that students were coming up with for some problems that we asked them in a recent camp, is they would constantly have one script updating a variable based on some sensor values, and then they would have another simultaneously executing script that would actually use them. So this is a real world thing that students try to do, and we do need to support it if we want them to have direct knowledge transfer. So if we just run this project, we see that the sprite just outputs the 2 counter values using this join block here. So let me go over to PyBlox. So this is the equivalent project. So we just have 3 onStart events and 3 infinite loops. So if students don't know how to do onStart, they can just drag and drop this green flag click, and it'll give them a little function stub that they can fill in. And they might not know how to make an infinite loop either. So if they drag and drop forever, you see it's just a while true, and then it tells them they can replace the code inside with whatever they want it to do. So if we go ahead and run this project, which you can do through the run menu up here, run project, another window pops up and we'll actually start executing the code. And we should see exactly the same thing. The sprite just has a little bubble next to it that outputs the 2 values, just like it was in NetsBlox. So let's see, we'll go over to NetsBlox now, and we'll just show some of the RPCs. So these 2, we saw NetsBlox a little bit before, but these 2 RPCs are new. So there's this Mauna Loa CO2 data service that we talked about before in the slide. So if you just click on this to see the result, it goes out to the server and gives you this, this table of values. And so you can directly put it into another RPC called on the chart service called draw. And if you click that, it'll give you a little image right here. And if you just plug this into, well, let me get rid of the costume so you can see it work. If you just plug that into a switch to costume block and you go ahead and run it, you see that the sprite switches to a plot of that data. And so just to show how simple this is, we'll actually just make a new project in PyBlox, wipe out everything. We'll start with a green flag click script, so we can just drag and drop that in. And now we'll go ahead and do nb dot, and then we see this list of services that we can access, but we wanted the Mauna Loa CO2 data service, so we can just do MAU, and we have tab completion. So then we just want to get the CO2 trend, so tab again, and the default arguments are fine. And you know what the default arguments are here because there's some documentation about what they do. So this will actually grab us our data. So we might want to save this to a variable for now. And then we'll produce an image. So we'll just make a new variable for that. And what we were doing before was calling the chart service. So we'll just still do that. And then we'll go to draw, and we just need to pass it the data. So this will give us an image, and we can just assign that directly to our costume by doing self.costume equals image. So now we can just go ahead and run this project and convince ourselves that it works, or that I mistyped something. No, it works. Excellent. So we see right there, it's still a one-to-one correspondence, even when we're using these more advanced networking features, accessing web APIs and services. So another one that we'll show you a little bit more complicated. There are several example projects that come built in with the IDE, one of them being Street View. So I'll just switch over to this one. Now the code is a little more complicated, of course, but it's really just more of the same. And we do have students do the equivalent of this project in NetsBlox, and the conversion is pretty trivial once students get to know Python syntax. So if we just go ahead and run this project, what it goes out and does is it contacts the NetsBlox server and grabs map images from Google Maps, and we can actually pan around. It fully implements, and this is all code that students would write, so either in blocks or in PyBlox. For panning around, there's also zooming, and if you click anywhere, it'll actually jump down into Street View, and students can rotate around and do those kind of things. So we also want to make sure that in addition to the other things that we want to support when we transfer knowledge from a block-based environment into some other language, we want to also use the specific properties of the target language, in this case, Python. So Python has a function called input, which is the normal way by which you get input from the user, instead of these key presses that we're doing for here. So if you press the Q key, this project will go and ask for input from the user. So we can actually just, as PyBlox does, we can actually just rebind this to open a modal dialog where we can type an address. So if I just say Paris and hit OK, it'll jump directly over to that location using the geolocation service on NetsBlox. And a lot of this is just NetsBlox specific things, so don't worry too much about the specifics of that, but just know that these are basically just features that we would normally use in NetsBlox, and we've transferred over to a functioning form in Python pretty directly. So I think the last thing that we'll talk about is actually that the NetsBlox code is actually so similar. Let me go ahead and open Compass. There we go. I need to grab a tablet. Okay, so let me just open this up. Oh no, I forgot to type the ID. Wonderful. 1 second. E7283031. Okay, I think that'll work. Okay, so if I go ahead and run this project, I have a tablet with me right here, and this is just a normal NetsBlox program that we would do that accesses a service called Phone IoT that allows you to read these sensors from tablets and phones and things like that. So if we go ahead and stop that, now that we know that it's working, and just go over here. So I've actually just exported that project directly from NetsBlox, and there's this option here called Import NetsBlox Project. So we can actually just click that NetsBlox project, import it. And because there's this high similarity to the NetsBlox code, just a one-to-one correspondence, we can actually have a compiler translated version. So this is an equivalent Python program that does exactly the same thing. Now it's a little messier than what students could write using PyBlox on its own, but it does work much the same. If I just go ahead and run it quickly, yes, we see it's like that. Now I'm just about out of time. So the last thing I'll say is that the real thing that we want to do with this tool and some of the three things that we talked about before, concurrently executing scripts, event-based computing, and graphical environment support. These are all things that students know, and they know very well from Snap and NetsBlox. So when they transfer over to a text-based environment, they might feel like they've lost information, but they really haven't. We really just need to give them access to that knowledge. They know how to do it, they just don't know how to do it in this new environment. So really the process is just making a sufficiently simple interface that students can use their existing knowledge and transfer it over pretty much directly. And the last thing, I'll just, there's a page of resources. I will attach this to the materials on the SnapCon website later if anyone is interested in that. But otherwise, yes, sorry, I went a little bit over, but that's all. Thank you.